Hello everyone, my name is Fasika Imam. I am a physics instructor at Kelebawiyan International Academy. My today's presentation is for 12 graders national exam candidates. And today we will look at some major points about kinematics. As you all know, kinematics is a branch of mechanics which studies about the motion of an object excluding the cause. In our today's lesson, we will focus on motion in one dimension and motion in two dimension. So, kinematics studies motion without delving into what caused the motion. And motion is a continuous change in position of an object with respect to another object over time. And this motion is always relative. When one says that an object is moving, he or she is comparing the position of that object with another object. When describing something that is moving, you are comparing it with something that is assumed to be stationary or not moving. The frame of reference is a background or object that is used for comparison. For example, suppose you are on a train that just left the platform. So the people standing on the platform see you moving away because they take Earth as their reference frame. But the person sitting next to you does not see you moving because his frame of reference is the train. Basically, we have two frames of reference. The first one is inertial frame of reference, which is points are not being accelerated and Newton's laws are easily observable. But for non-inertial references, points are accelerated frames of reference and Newton's laws appear to break down in these reference frames. Now, let's look at some important terminologies in kinematics. Let's compare and contrast distance with displacement. So as you can see on the screen, the length of the blue path is a distance traveled, whereas the red arrow or the vector is the displacement. So when we say distance, it is a scalar physical quantity and it is defined as the total path length of a journey, whereas displacement is a vector physical quantity and it is the shortest path length directed from the initial point to the final point. And the sign of both distance and displacement is meter. The other one is position. So position is measured relative to a reference point. And this position has sign. If you take the origin as a reference, then we will have positive direction in the direction of increasing in numbers and negative direction in opposite to the positive one. And a change in position is called displacement. And to find the displacement, we have to subtract the initial position from the final position, average speed. So speed is defined as the distance traveled divided by the time taken. And when we say average speed, it is the total distance traveled divided by the time taken to cover this distance. And since speed is a scalar physical quantity, it has no direction. And the sign of speed or average speed is meter per second. Average velocity, it is defined as the time rate of change of displacement, meaning it is the change in position per unit time. And in this case, velocity is a vector physical quantity and its SI unit is meter per second. The other type of velocity is instantaneous velocity. So instantaneous velocity is defined as the velocity of an object at any instant of time, or it is the velocity of an object at a single moment in time. And mathematically, to calculate this instantaneous velocity, we use the limit of change in x over change in t, where change in t close to 0. Or if x or position of an object is expressed as a function of time, then the first derivative of this displacement with respect to time will give you the instantaneous velocity. Acceleration. Acceleration is defined as the time rate of change of velocity. When we say average acceleration, it is final velocity minus initial velocity divided by the time taken to change this velocity. Whereas talk about instantaneous acceleration or simply acceleration, it is the acceleration of an object at a certain instant of time. And to calculate or to find this acceleration, we have to use first derivative of velocity with respect to time or second derivative of displacement with respect to time. So we can categorize motion into two as uniform motion and uniformly accelerated motion. So in a uniform motion, the velocity of the object remains constant. And when an object moving along a straight line covers equal distance in every time interval, then it's said to be having uniform motion. As you can see on the screen, we have two graphs which shows this uniform motion of an object. So for a distance versus time graph, you will have an inclined straight line to define uniform motion. And if you take any 2 points from the graph and find the slope of the graph, this slope is the same as the speed of that object or the velocity of that object. And second graph is the speed versus time graph. And in this case, since we have a constant speed in a straight line, then the speed versus time graph will be a line which is parallel to the time line. And the area enclosed by this speed versus time graph will give you the distance covered by that object during the specified time. When you compare this uniform motion and non-uniform motion on following this graph, when you compare this uniform motion with non-uniform motion by looking this graph on the screen, the first one, as you can see on the screen, is a horizontal line. It is a velocity versus time graph, meaning the velocity is constant, so that the motion is uniform motion. But on the right hand side, there is an inclined straight line, and in this case, the velocity is changing linearly. We have no constant velocity, and therefore it is non-uniform motion. The second type of motion is uniformly accelerated motion. In a uniformly accelerated motion, the acceleration of the object remains constant. When an object moving along a straight line changes its velocity linearly in every time interval, it is called a uniform motion, and the motion is said to be a uniformly accelerated motion. When an object moving along a straight line changes its velocity linearly in every time interval, the motion is said to be uniformly accelerated motion. As you can see on the screen, we have two different graphs, and the left hand side graph shows velocity versus time graph, and it is an inclined straight line, meaning the velocity is changing linearly with respect to time, so that the slope is constant, and the slope of velocity versus time is acceleration, and therefore this graph refers to uniformly accelerated motion. But when we see the right hand side graph, there is a variation of velocity, but it's not in a linear way, and therefore the motion is non-uniform accelerated motion. So whenever we have a uniformly accelerated motion, since the velocity of that object increases at a regular interval of time by a certain regular amount, we can apply the following equations to solve different problems, okay? And these equations are called equations of uniformly accelerated motion. The first formula is definition of acceleration, which is a equals v2 minus v1 over t, where v2 is the final velocity and v1 is the initial velocity. And the second one is d equals v1t plus at squared over 2. And the third one is d equals half of v1 plus v2 times t. Here, half of v1 plus v2 means the average speed or the average velocity. In this case, we can use this formula v1 plus v2 over 2 if and only if the motion is uniformly accelerated motion. And the fourth one is v2 squared equals v1 squared plus 2ad. And finally, we can also calculate the distance by using v2t minus at squared over 2. So in all cases, when we say v2, it is the final velocity, and v1 is the initial velocity or speed, assuming that the motion is rectilinear motion. Let's come to free fall. So when the only force acting on an object is gravity, then the object is said to be in free fall. In a vacuum or no air, all objects in free fall accelerate at the same rate, regardless of the mass. In a vacuum or no air, all objects in free fall accelerate at the same rate, regardless of mass. On Earth, gravity is not the only force on an object in free fall. The acorn falls faster than the leaf because it has less air resistance. But in vacuum, acorn and leaf fall at the same speed. So far, we have seen some major points about motion in a straight line or rectilinear motion. Now, let's look at some points on motion in two dimensions. In a two-dimensional motion, we have projectile motion and circular motion. For the time being, let's look at projectile motion. So, for two-dimensional projectile motion, it is a motion of an object moving in two dimensions which are under the influence of gravity. An object is thrown or launched into the air and whose motion is subject to gravity's pull. And we have two types of projectiles that are called horizontal projectile motion and inclined projectile motion. And projectile motion is essentially free fall motion with an initial horizontal velocity or initial horizontal and vertical velocity. When an object moves in two dimensions, we can consider the two components of its motion separately. For example, in the case of projectile motion, the gravitational acceleration only influences the motion in the vertical direction, and in the absence of an external force, there is no acceleration in the horizontal direction, and the velocity in the direction is thus constant. As you can see the diagram on the screen, along the horizontal, motion of a ball rolling freely along a level surface, and its velocity in that direction is always constant. But when we see the vertical one, its motion is freely falling motion, and there is only a single force, which is force due to gravity. And since there is an acceleration along the vertical direction, the vertical component of velocity changes with time. And the combination of this horizontal and vertical motion will give us a parabolic trajectory or path. Here you have to bear in mind that there is one assumption for such kind of motions. It is there is no air resistance, or we assume that air resistance is neglected. So when we look at equations for horizontal projectile motions along the horizontal direction, since the speed or the velocity is constant, then to find the horizontal distance or range, you can simply calculate the horizontal speed Vx times the time taken to reach to the ground. And along the vertical direction, it acts like a freely falling motion, and therefore you can use equations of uniformly accelerated motion for the vertical one, and therefore the vertical distance change in y is simply half gt squared, and the final velocity along the vertical direction is g times t. Or you can also use v final y squared equals 2g times y. And to find the overall final velocity as the object strikes the ground, it is the same as v final squared equals v final along the x squared plus v final along the y squared. Let's look at this example. A plane traveling with a horizontal velocity of 100 meters per second is 500 meters above the ground. At some point, the pilot drops a bomb on a target below. The questions are: how long is the bomb in the air, and how far away from point above where it was dropped will it land? So the initial velocity along the x-axis is given, which is 100 meters per second, and this motion is a horizontal projectile motion, and vertically it is 500 meters above from the level ground, which is the height is given. And since the projectile motion is a horizontal projectile motion, the initial velocity along the vertical direction is simply 0, and acceleration due to gravity is minus 9.8 meters per second squared. And we are asked to calculate the time taken to strike the ground and the horizontal distance covered by the bomb. So to calculate the time taken, you can simply use y equals half gt squared, where y is the vertical height, g is acceleration due to gravity, and t is the time taken to cover that trajectory. So by substituting the value of y and g, you can make t to be the subject, and finally its value will be 10.1 seconds. Now if you know this time, the time taken to cover the vertical distance and the horizontal distance of the trajectory is the same, and hence you can use this time to calculate the horizontal distance or the range, and therefore x equals v naught x times time, where the horizontal speed is 100 meters per second and the time taken is 10.1 seconds, and therefore the horizontal range covered by the bomb will be 1010 meters. So when we look at inclined projection, since projectile motion is a combination of two perpendicular motions or vectors, each motion is independent of each other. Along the vertical direction, there is gravity, and this gravity does not affect the horizontal speed Vx. And similarly, this horizontal speed Vx has no effect on Vy. And when we look separately the horizontal motion of this inclined projectile motion, there are no forces affecting the horizontal motion, meaning the acceleration along the x-axis is 0. But along the vertical direction, there is an acceleration due to gravity. And together, these components produce what is called a trajectory or a path, and this path is a parabolic in nature. An inclined projectile motion, you can use the following equations. For instance, to calculate the horizontal distance x, or sometimes called r, which is a range, it is calculated by v naught times t times cosine of theta. where v naught cos theta or u cos theta is the x component of the initial velocity or the horizontal component of the initial velocity. To find total time of flight of this path or trajectory, you can calculate t equals 2u sine theta over g. Again, here u sine theta means the vertical component of this initial velocity. Again, the range of the projectile can also be calculated by u square sine 2 theta over g, and the maximum height of the trajectory will be u square sine square theta over 2j. Here, the range of projectile can also be expressed as 2 times the initial velocity along the x-axis times the initial velocity along the y-axis divided by acceleration due to gravity. Let's look at the following example which supports this idea. Inclined projection. A place kicker kicks a football with a velocity of 20 meters per second and at an angle of 53 degrees above the horizontal. The first question is how long is the ball in the air, and second one is how far away does it land and how high does it travel. Here it is given that the initial speed is 20 meters per second and it makes an angle of 53 degrees above the horizontal, so we can resolve this velocity along the horizontal and the vertical direction. And to calculate the horizontal component of the initial velocity, v naught x equals v naught cosine of theta, which means 20 times cosine of 53 degrees, and it is equal to 12.04 meters per second. And similarly, you can calculate v naught y by v naught times sine theta and substitute this v naught in theta, and so that the final value of the initial velocity along the vertical direction will be 15.97 meters per second. Now, taking these values as a given, to calculate the time taken covered by this ball on the air, then y equals v naught y times t plus half gt squared. But initially it starts from the level ground and finally it strikes the ground, meaning the final displacement y will be 0. Therefore 0 equals 15.97 t minus half of 9.8 is 4.9, so that it will be minus 4.9 t squared. And you can rearrange this and calculate the value of t, and finally t equals 3.26 seconds. And the second question is how far away does it land, meaning we are asked to calculate the horizontal distance or range. Since we already know the value of t, you can simply calculate this x or the range by multiplying this v naught x by t, which is 12.04 meters per second times 3.26 seconds, and this is equal to 39.24 meters. The third question is how high does it travel? So we are asked to calculate the maximum height. So here we can use this equation, which is vertical height y equals v naught y times t plus half gt squared. So to calculate the maximum height, if you use this formula, you have to take half of the time taken, because total time is for the whole trajectory, but to reach to the maximum height we need half of the total time. And therefore, since we use this equation y equals v naught yt plus half gt squared, instead of substituting total time, we have to use half of the total time, which is 1.63 seconds. And finally, when you substitute all the values that are given, then the final height or the maximum height will be 30.01 meters. So the last point for our today's discussion is relative motion. So the velocity of an object measured by an observer depends not only on the motion of the object, but also on the motion of the observer. For example, rain appears to fall at an angle theta when the observer is moving in horizontal direction, and the relative velocity of two drivers going at 55 miles per hour in the same direction is 0 miles per hour. So when you come to relative motion in 2 dimensions, the procedure to relate the observations different observers in 2D or in 3D is similar to what we did in 1D. So the relative velocity of one object with respect to the other is equal to the difference between these two velocities with respect to their common frame of reference. And here are the formulas to calculate the relative velocities between two moving objects with respect to their common frame of reference. I hope you enjoyed our today's lesson, and that's all for today. Thank you.